Okay, picking up with our solutions to our trig worksheet. And once we've done the solving in the last one, so in this one, we're going to be taking a look at some of the multiple choice and the other problems that you have. Here we're taking a look at, remember these are the ones where you have the composition, the cosine of the angle whose sine ratio is negative square root of 3 over 2. Remember arc sine or inverse sine. This is the angle. And you do have to remember that this angle that this is returning has to be in the window, the principal value range for sine is negative pi over 2 to pi over 2. You do need to know them for all three trig functions. Cosine, the inverse cosine is between 0 and pi. The inverse tangent is between negative pi over 2 and pi over 2. Those are the three main ones that you need to know. So this one we also recognize as we're doing the problem that we have a special angle ratio. So it's a unit circle. We don't have to draw triangles. We're just unit circle. What do we know? So I first figure out the angle whose sine ratio is negative square root of 3 over 2. I know that I'm in the pi over 3 family, but I need to be in between negative pi over 2 and pi over 2. So I'm going to have to be down here in quadrant 4. And so if I'm over here in quadrant 4, what you want to do is make sure that you're in between negative pi over 2 and pi over 2. The mistake that I usually see is you guys will tell me, hey, I'm in the pi over 3 family, I'm in quadrant 4, so 2 pi minus pi over 3 is going to give me, sorry, I had to do my fractions in my head. Pi or 2 pi is 6 pi over 3 minus pi over 3 would be 5 pi over 3. So a lot of times you guys will tell me 5 pi over 3. But the problem with this is while it has the right ratio, it is not between negative pi over 2 and pi over 2. So what I'm going to do is I'm going to find coterminal. I'm going to subtract 2 pi to get myself in the right range, and that's going to give me negative pi over 3. Negative pi over 3, 5 pi over 3, coterminal, but for the inverses, it has to return the angle that has this ratio in the principal value range, and so our only answer is negative pi over 3. Inverses are different than what you do when you're solving. If I was solving, like what we were doing up here, what we had was something like here, cosine of x equals 1/2. We wanted all the angles x that have a cosine ratio of 1/2. That's a different scenario than for looking at the problem down here, which just says, I want the one angle, only one angle that has the sine ratio in this principal value range. And so that's why you have two parts to this you have to pay attention to. And then we just have to take the cosine of negative pi over 3. We're in quadrant 4. It's positive for the cosine, and the cosine ratio in the pi over 3 family is 1/2. And so we're done with that one. Over here, this one, not on the unit circle. It's actually an algebraic problem. So this is one of those ones where we're eliminating the trig functions and turning it into an algebraic expression. This is find the tangent of the angle whose secant ratio is 3x. Now, sometimes when I do these, when you have the reciprocal function there, a lot of times I may go ahead and switch that to its reciprocal function. And now just be careful. Notice I said the tangent of the angle whose secant ratio is 3x. So the cosine ratio, which is the reciprocal, would be 1 over 3x. So sometimes I do that to start the problem out. This is a draw a triangle problem. Cosine, inverse cosine, has a PVR, principal value range. This angle that we're looking at has to be between 0 and pi. So I'm going to be drawing my triangle here in quadrant 1, and you can also draw it in quadrant 2. But we will see, kind of similar to the example that we had, is that it really kind of does matter when you're doing this one. Like let's do quadrant 1 first. So in quadrant 1, I would do adjacent over hypotenuse, 1 over 3x. And then I would find the third side. We would go ahead and do our Pythagorean, square the 3x. That's 9x squared minus your leg squared. And so if I was just looking at quadrant 1 to find the tangent of the angle whose cosine ratio is 1 over 3x, then the tangent would be square root of 9x squared minus 1 over 1, or square root of 9x squared minus 1. Now, let's address the other quadrant here before we walk away from this one, because in one of the previous examples, they kind of worked out to be exactly the same. But what we're looking at here is the angle whose secant ratio is 3x. The angle whose secant ratio is 3x. Now, that secant ratio could be negative. And if the secant ratio is a negative number, when you're doing this, because x is negative, it does a little bit of a interesting thing to the problem in that we have to take it into account that we have a negative number. And what's weird about this is when you're looking at it, this right here, 3x, the hypotenuse is always positive. It's always a positive number. So if the x, or what's here, 3 times whatever this x is a negative number, it's this part that is the negative. Now, in terms of our solving, does it really matter that I put that absolute value there on the 3x? Because I know that radius needs to be positive. When I go over here, this hypotenuse is going to still be the same thing, because when you square this, which is positive, you're still going to get 9x squared. It's still going to be the square root of 9x squared minus 1, because when you square negative 1, it becomes positive. And so over here, this part, you're like, hey, is that going to be the same thing? What's different is it's going to be a positive over a negative. And so this actually means that you have 2 options for this division depending on what quadrant you're in, and that's going to add this additional plus or minus in for that one. Now that one's kind of challenging, mostly because you got to pay attention to your sign and what's going on with each of these triangles. Make sure you look at triangles in both of the quadrants for the principal value range. 90% of the time, it's going to be the same answer, but sometimes you'll get something like this where you have to take into account that depending on whether this is positive or negative, your tangent will be positive or negative depending on which one it is, because tangent's positive in quadrant 1, but negative in quadrant 2. So put that in there. All right, let's take a look at the next page. Now we're into the multiple choice. Let's kind of talk about, we want to try to do these as quickly as possible. So on something like this, we're trying to find the graph of a function. And now if this had just been sine of parentheses 4x, you're like, hey, it's just a sine graph. It got shrunk by a fourth, which means it repeats 4 times as much in the 0 to 2 pi window. We know that our period, and again, I'm just ignoring the absolute value bars for the moment. I know that the period would be 2 pi divided by 4, because it would be 1/4 of what it used to be, which is pi over 2, or approximately 1.57. So initially, when you look at this, a couple of things that you might be thrown off by. Now, let's talk about the absolute value bars. If this is a positive value, if x is positive, then these absolute value bars do absolutely nothing. So you're looking at, for x greater than 0, it's simply going to be the sine of 4x. You can think of this as a piecewise function. So it's sine of 4x if x is greater than or equal to 0. So we can keep that in mind, and that will help us eliminate some things. Like over here, B, clearly not the answer, because that is in no way our sine of 4x with nothing funky going on, okay? Now, A is still a possibility, okay? So we'll underline that. It's a possibility because if you look here, that period, it's about 1.57. You can't really tell, but that's kind of where the target is. So, and it's a sine graph. It starts at the intercept max, intercept min, intercept. So that one's still in. Let's see, let's scroll down here and see what my other options are. This one is going to be out. The reason that I know this one is out, it has about the right period, but the problem is it goes max, intercept, min, intercept, max. That would be this portion right here is cosine of 4x, which is not what we're looking for. Okay, we'll take a look at this. On this one, this positive side, it is a sine function, but the problem is period looks like it's a little bit over 2. So I would eliminate that one because it doesn't have the correct period for the positive x values. And then we'll look down here at this bottom one here, E. We've got a period of about 1.57. It's got a sign pattern. So this one is still a possibility, okay? So we use the what's happening for the positive x's first. And now we'll look at what's happening with the negative x's. So we can eliminate, because right now we're down to either A or E. Now, we know that when x is negative, that the absolute value bars will make it positive. It will make it positive. And so what that tells me is that when we have, so if x is less than 0, okay, this is going to make it, how do you make something positive? If you have a negative value, to make it positive, you multiply by a negative. So here, if x is negative, what you're really going to do is negative 4x. And then you think about what transformations happened, and you're like, hey, for the negative values of x on the left side, this is going to have a horizontal flip of what sine of 4x is. This right here is not a horizontal flip. If I take this and flip it over the y-axis, a horizontal flip, it's not going to go down here. It should come back up because you're going to see a mirror image over the y-axis. That's what you're looking for. So I would take this one out. And so pretty much our only choice here is going to be E. Now, another way of looking at this is that these absolute value bars, essentially what they do whenever you have absolute value around the input is it always makes the function even. And so that's another way to look for it, is to think about symmetry, and this symmetry has even symmetry, so that's what we would look for. So kind of a lot going on in that one, but kind of gives you the idea of how you're going to do the problem. Okay, how much time do I have? I have 4 minutes. I'm going to skip number 8 for the moment because that's a little bit longer. I might want to do that one separately. Let's do this quick one right here. You have a graph. Here's some transformations, shift up or down, vertical scale, horizontal scale. What's the value of B? Well, B is your vertical scale, also known as your amplitude. So that's fairly simple on this problem. If you think about where your midline is, the middle of the graph, it's coming across here. So the midline is about negative 1.5, negative 1.5. And then you want to see your amplitude is the distance from your max to your midline. So I don't know how far up this is, and it goes 1, 2. So it's up 2 from the midline. So what's the value of B? The value is 2. So our choices are, there we go. So we have an amplitude of 2. So we're done with that one. All right, let's see if this one's a quick one. This one we can go ahead and plug and chug. This is function notation. F of pi over 6 just means plug it in. 4 sine pi over 6 plus 6 cosine 2 times pi over 6. Valuation, that's all this is. Sine of pi over 6 is 1/2. This is cosine of pi over 3, which is also 1/2. So this ends up being 2 plus 6 times 1/2, 2 plus 3, or 5. So the answer to that one is F. The range here, again, you're just playing around with your horizontal and your vertical transformations. Range is the vertical. We have a stretch by 2. So we go negative 1 to 1. We stretch by 2, negative 2 to 2. And then we go down 1. And when you go down 1, you're at negative 3 to 1. So negative 3 to 1, the answer is B. So that was a nice quick one for your cosine. All right, let's look at, is there one below? All right, this one right here, let's see, in the interest of my time, I think I'll stop this video and I'll come back and I'll do the 2 harder ones here, and then we'll be done with this worksheet.